Hey guys, this one's going to be about weak base, strong acid titrations. All right, so an acid-base titration with pH monitoring. Talked about this in the last video, so here's the setup. So in this situation, we would have acid here, probably strong acid, and we would have weak base here. What is happening? Weak base in the container here, and we're adding strong acid, and so we're generating a curve. So it's starting out with a weak base, and it will look something like that. So pH is over here, and then this would be the milliliters of acid added. We have the same thing is happening here as in a weak acid titration, but instead we have a weak base, so the pH is going to start high. And if you'll note that the equivalence point here is less than 7, that's how we know that it was a strong acid that was being titrated into a weak base. All right, and so I know that in the container here I had base because my pH is high, and since my pH is less than 7, it had to be strong acid in this. And so remember at point 0, that's when I haven't added anything from the burette yet. There's nothing been added yet. So there had to be base down here. All right, so the few points that I want to talk about here. The first point is, when we have just the base, right? And so if you have weak base and we haven't added anything to it, it's going to be right here at this point in the titration curve. So that's why the pH is so high, because we're producing hydroxide, right? And then once we start adding acid to that, the acid's going to react with the base to produce the conjugate acid. So that is this point, and that at that point we have made a buffer, right? Okay, and then the third point is at the equivalence point. So at the equivalence point, we have added enough acid to neutralize all of it and not have any excess acid left over. So we've created an acid here, a weak acid, and that weak acid will dissociate some of the H off of it. And so because of that, the pH is going to be less than 7, right? So it's because we've produced conjugate acid only. So beforehand, on number 1, we have excess base. We've made a little bit of conjugate acid, but not much, and we have hydroxide in solution. During the buffer region, we have base and we have conjugate acid. And so then you're also going to have some hydroxide in there, right? It's still basic. And then at the equivalence point, we have just conjugate acid. And so that conjugate acid is going to produce hydronium in solution, and that's going to cause the pH to be less than 7. Now, the fourth point is after the equivalence point, you're going to have all of the base will be gone, but then you have excess acid, and you have conjugate acid in there too. And so that's why the pH comes so low down here. So those are the 4 main points for weak base strong acid titration curve. And then this slide just basically summarizes that. Okay, so you see this curve at the beginning. I didn't really show that on the last one, but that's that curve that I'm talking about where the buffer has not been formed yet. The conjugate acid has not been produced in enough concentration to make a buffer. All right, and so then you get this buffer region and then the equivalence point. And so I do want to talk about the half equivalence point here. So this looks like this is happening at about 25 milliliters. And so 12 would be about right here, 12 and a half. So what we do there, if the pH is equal to the pKa, right? We want to know the pKb usually for an acid, and the pOH has to be equal to the pKb. So you can just find your pKa from here, and then 14 minus the pKa will give you the pKb. All right, so this would be the pKa for the conjugate acid because you're looking at the pH. And you find it the exact same way. But I know that this is going to be a weak base with a strong acid because of where the equivalence point is. Now, if your equivalence point is at 7, that means you have a strong acid, strong base, and all of this stuff doesn't matter because you're not going to have a buffer at all.